Okay, here we go. We're going to deal with some limit lingo and some non-limit lingo. So the first thing I want to mention to you is symbols, which I did not choose. So S at T, regardless of how little sense that makes, represents distance or displacement. For those of you who are going on to calculus class, distance is a scalar quantity and displacement is a vector quantity. We'll get to that in a minute. V at T, logically, thank you very much, represents speed or velocity. Both of them at time t, since there's a t in the bracket. And again, speed is a scalar quantity and velocity is a vector quantity. So first of all, what's a scalar quantity? A scalar quantity is just a number. So for instance, 45 kilometers per hour. So I guess a number and units. So what that is considered is it's a magnitude. It's an amount. A vector quantity, on the other hand, for those of you going on to calculus, would be, for instance, 45 kilometers per hour north. So a vector quantity has a magnitude, so it's got a number associated with it, an amount, and it's got a direction. So up, down, north, south, east, west, to grandma's house, from grandpa's house. Whatever the case is, it's got a magnitude and a direction. We're not going to worry so much about that now. I thought I'd preview the vocabulary for those of you taking calculus. Our vocabulary is looking for the word average. So average is a very important word. So we're going to look at that for a little bit, and then I'm going to change things up. So the first question is, determine the average velocity between 2 seconds and 5 seconds for S at t, so that's a distance formula, equals t squared plus 5, where S is measured in meters. So it implies that time is measured in seconds and distance is measured in meters. So that's stated outright, that's implied. So now let's talk about an average velocity formula. So the average velocity formula looks like this, and it's given when you're given 2 times. And I have no idea why there's that little space, but you should sort of recognize this. S at t2 minus S at t1 over t2 minus t1 should look a heck of a lot like, drum roll please, slope of the secant. So if you prefer, instead of using S's and T's in this case, or H's and T's if somebody gives you height, you could go back and do the y2 minus y1 over x2 minus x1. So for instance, I'm going to start a little list here. Slope of the secant is y2 minus y1 over x2 minus x1, or an equivalent. And that's the same thing as average velocity, or actually average anything. Now, we're talking about speeds and distances and times, so that's where we're going to have average, specifically velocity. So I'm not going to use any other letters but this. So the first thing I'm going to do is know that X's and T's are the same thing. So I need a T1 and I need a T2. Now this question is supposed to be fairly easy because it says specifically, determine the average velocity between 2 seconds and 5 seconds. So my first time is 2 seconds, and my second time is 5 seconds. So I have to figure out S at t1, meaning I have to figure out S at t1 is 2. And we have to put that into the formula, which is t squared plus 5. So that's 2 squared plus 5. So 4 plus 5 is 9. And then I have to do the same thing to find s at t2, which is s at 5. Because remember, you put t1 in to find that, you put t2 in to find that. So in this case, 5 squared plus 5, so 25 plus 5 is 30. So then we can dig out the formula. So average velocity equals s at t2 minus s at t1 divided by t2 minus t1. And I'm going to write the rest of it here, knowing that I'll drag it down because it's really bad practice to have two equal signs in one line. But t2 is 30 minus t1 is 9. Sorry, s at t2 is 30, s at t1 is 9, t2 is actually 5, and t1 is 2. So what you should notice is that these two things are stacked, and these two things are stacked. That's something to pay attention to for sure, in case you are careless or sleepy like me. So I'm going to group all this together. And drag it down a little bit. So 30 minus 9 is 21. 5 minus 2 is 3, so that answer is 7. Now, we're going to have some units for this. So you have to go back and find out that the s's are measured in meters, and the times are measured in seconds. So this is meters per second. And that is the end of average velocity. So average velocity is nice. It is friendly. You're supposed to be quite happy with this. No limits in this area. Limits kick in when we talk about slope of the tangent, and it kicks in when I give you some new vocabulary. So, next question. Determine the average velocity between t equals 2 and t equals 2 plus delta t. Now, I don't know about you, but I don't want to use the delta t, so I'm going to go back to the h, and I've communicated the fact that I am going to do that. So, average velocity again. We're super happy about this. And I'm going to make my list. So t1 is 2, t2 is 2 plus h. Now you have to be aware of where you've done work before. For instance, if I go back here, I already know that when I sub in t is equal to 2, I'm going to end up with s is equal to 9. So s at t1 is equal to 9. There we go. This one, not so easy. I have to do s at 2 plus h. So I'm going to go back and find my formula, which is t squared plus 5. So we're doing all the same things. T squared plus 5 So instead of t squared, it's 2 plus h squared plus 5. FOIL time. So that's h squared plus 4h plus 9. Now, I'm running out of room, so I'm going to take a little break here for a sec and move my stuff around. All right, so moved around. I am doing average velocity, which is the equivalent of slope of the secant, only with a different label here. Here's the formula. in case you need to write it down over and over again. And find your values. So h squared plus 4h plus 9 is the s at t2, minus 9 is the s at t1, over 2 plus h minus 2, t2 minus t1. So this 9 minus 9 will be 0, and this 2 minus 2 will be 0. So I've only got this stuff left, and hopefully you can see that this is the exact same kind of question as we were asking in the last lesson, which was all about slope of the tangent and slope of the secant. So I'm going to factor out an h, because I can. Remember, everything relates back to one of the different methods. So this didn't have a square root, so it wasn't the conjugate method, and it didn't have a triple layer fraction, so it wasn't the common denominator method, so it must have been the factoring method. And now I have a very incomplete average velocity because I didn't tell you how much the smidgen was. I didn't tell you how far away the second time was from the 2-second mark. I do know units, however, so I'm going to do that. All right, so average velocity, secant, same thing, same steps, no fooling around. Now I'm going to find the instantaneous velocity at t equals 2. So the nice thing is I didn't change the number on you. This was all about 2 in average velocity. This is all about 2 in instantaneous velocity. Under this box is some stuff I'm going to have to fix, so bear with me. So first of all, let's delete the box. And I just want to show you, number one, my fixes. So this should say delta t, delta t, delta t, t approaches 0. So this formula for instantaneous velocity is actually the same as the limit formula for slope of the tangent. So over here on the side, in my tangent color, blue, slope of the tangent is limit as h approaches 0 of slope of the secant. So we always steal our previous answer. It'll be instantaneous velocity is an equivalent, instantaneous anything, or just straight velocity, which is why I've got instantaneous in a bracket like this. And here, it's because I don't have to say instantaneous. I can just say velocity. What matters is the absence of the word average. So average makes you work without limits. And as soon as I take away the word average, I am working with limits. So the reason that is the case is this stuff I've got written in no coincidence blue. Instantaneous velocity is the velocity at a certain moment. As delta t, the difference between the two times, becomes really, really small, that means it approaches 0, the average velocity becomes closer and closer to the instantaneous velocity. This is the same principle as Q, point Q, getting closer and closer to point P, which is when a secant line becomes a tangent line. So basically, what this little blurb here is talking about is it saying instantaneous velocity is one particular moment as opposed to average, which is average. It is over the course of time. So in order for me to do instantaneous velocity, where I can be super lazy and not write down instantaneous, or I can write it down, I'll put it in a bracket for the time being. And I always have trouble spelling instantaneous, even though it's up above there. So instantaneous velocity is equal to the limit as I chose to turn my delta t into an h. So it's h approaches 0. I get to steal this answer. And because I did all the work of factoring up here, just like slope of the tangent, I get to insert the number and do the math. So at t equals 2 seconds, this object, whatever it happens to be, is actually traveling 4 meters per second. So a little refresher for my brain. Yeah, I don't know what kind of object it is. I just know that it's traveling at 4 meters per second. Now, as I said, velocity should have a number value, units, and a direction, but we're not concerned about that until you get to calculus class. All right, second question. I think there's 3, but I'm not 100% sure. Yes, there is. I will uncover this box in a second. So here is the question. It says an object falls from a tall building. Its height in meters after t seconds is given by h at t is equal to, oh, excuse me, that was a yawn, 150 minus 4.9 t squared. And I hope that you guys in physics are recognizing one of the numbers in here, like this one. It says determine the average and instantaneous velocity after 1 second and also after 5 seconds. So to be perfectly honest, I have no intentions of going through all of this twice. Once for 1 and once for 5. I don't feel like doing that. It's getting kind of late. So what I'm going to do instead is I'm going to do what we did in the last note when I didn't give you an x value to start with for slope of the secant and slope of the tangent. I'm going to ignore this temporarily. I can erase this in a second. And I'm going to find a T1 and a T2 that are general. So I'm going to use T1 is T, just like I used X1 is X, and that makes T2 T plus H. It makes, in this case, H at T1 be the formula it is, because I'm putting T's in for T's. And unfortunately, here's where the work comes in. I have to take all my T's and turn them into T plus H's. And remember that that little 2 says, please write me down twice and FOIL. So I'm about to pull this off right now. Once again, I remind you that there is a difference between annoying and difficult. So my first step is to FOIL. T times T, T times H, H times T, H times H. I'm going to choose to multiply the negative 4.9 into the bracket. Before I collect like terms. And then I'll collect like terms. And again, you physics students should recognize a number right about now. You can't do physics without math. No more like terms. So time for average velocity, first of all. The average velocity would normally be s at t2 minus s at t1. This time it's h's, so I should make an adjustment. Denominator will stay the same. T2 minus T1. And then I can find my value. So h at T2 is this ugliness. Oh, I feel a hand cramp coming on. Minus h at T1, this tiny little blurb. And if you do this, you have forgotten that a quantity needs brackets after a subtraction sign, or it needs math. And then in the denominator, T2 minus T1. Cancel, cancel. H 150 minus 4.9 t squared minus 9.8 TH minus 4.9 T. Oh, typo. Why didn't you yell at me earlier? H squared. H squared. H squared minus 150 plus 4.9 T squared. Whew, that was a close one. So this 150 cancels with the negative 150. This positive 4.9 T squared cancels with this negative 4.9 T squared. And these two chunks of information, so I would have caught it at some point, should contain H's if you're doing things right. So they do. I'm going to common factor out an H so that it's slashable with that bottom one. For those of you who recognize that you could take out more than an H, yes you can, but the whole point of this is that so there's no need to common factor out anymore. If you want to, that's impressive. If you don't want to, that's fine. So I am at a point where I have the end result of average velocity, generally speaking, which is that. But I'm not asked for average velocity, generally speaking. I am asked for average velocity and instantaneous velocity at the 1 second mark and at the 5 second mark. So I'm going to split my page. And on the left side of my page, T is equal to 1 second. And on the right side of my page, T is equal to 5 seconds, and I don't have to do all of that part twice. So average, I should probably stick with red. Average velocity for T equals 1 is that amount, which I can then flip to blue and do straight up velocity. I don't have time or hand cramp ability for the word instantaneous here. I've got a lot more to come. Limit as h approaches 0 of negative 9.8 minus 4.9 h. This stays here until I am allowed to put in the 0, which is right now. This is 0, so I end up with negative 9.8 meters per second. I think we're still on meters per second. Meters seconds. So I've done 2 for 1. And now I can go back down to the bottom and I can do it all again for 5. Rather than all again from the start, I can go and carry on from this point. So negative 9.8 times 5, 45, 49, 1 decimal place. So that's negative 49 minus 4.9 h. Dig out my blue. Now, if you carry on like I am right now, I will have to take off marks. I'll tell you why in just a second. Even if you are a color coder like me, I will have to take off marks because you just switched or I guess in my case, I just switched from average velocity to instantaneous velocity. And if I switch, I must change the label that's sitting on the left. And because I'm at the end of this question, I will include instantaneous. So with or without, it's the same stuff. Now, back to this little box that I said I would uncover. This is the language of physics. So this is an object falling from a tall building. So when I talk about negative velocity, it means that an object is either falling backwards or it's traveling down. So in this case, the object is falling towards the ground. So you can have one of two therefore statements. So it's kind of lucky that I have two possibilities here, and I'm going to do real live therefore statements for you. I can say, therefore, the object is falling at, and because I've said falling, that takes the negative out of the number because you've stated direction, as opposed to this one where I can get pretty general, and I call it vanilla. Even though vanilla ice cream is delicious, it's kind of boring compared to, I don't know, death by chocolate. So I can say the height of the object is changing. Changing is a word that doesn't tell you whether it's going up or going down, in which case you have to state a direction, and that direction is indicated by a sign. So you can either use the oatmeal vanilla word of changing, or you can actually state a direction which takes out the negative. That's a bit physicsy. So I'm going to take a moment for a hand cramp break, and I will be back at ya. So I inadvertently lied. There's actually 4 questions. And this one is changing the language yet again, and it's asking to determine the rate of change of f at x equals 2 over x squared with respect to x at x equals 2. Now, before we start, with respect to, there is a short form for math teachers, and we need, basically it says that with respect to x means that I should have x in my answer. Now all the x's will be replaced by the number 2 because it's way easier to manage that way, but if you kept it as a letter, there would be an x in your answer. So the formula for rate of change, because I didn't say the word average, is basically the same formula as the first principles of calculus with the last lesson. It's the same formula as instantaneous velocity. You do the same thing over and over and over again with this stuff. Now let's see if I made this movable. No, because that would be too easy. The first thing I would do is I would create my list. And again, I remind you that this list is probably never to be seen ever, ever, ever in a textbook. They'll just jump into it. Also, probably with a calculus instructor, people jump right into it. So they do all this stuff, not on paper, but kind of in their heads. So x1 is the x value I give you, so thankfully there is one. And x2 will be 2 plus h. y1 will be taking 2 over x squared, and instead of x squared, it'll be 2 squared. So that's 2 over 4, so that's 1/2. And then a little clunkier, I'm going to put it down here so I'm not squishing too badly, is we have to figure out y2, which is 2 over 2 plus h squared. And I'm not sure I have to yet, but I'm a pretty good foiler, even though it is annoying. So I'm going to foil this here instead of part of the larger question. Now, right after we're done this, you have to make a decision. It's based on your laziness, not on your math. And that is, do you want to do y2 minus y1 over x2 minus x1, which is this stuff, with this in it every single line the length of the way to go directly to rate of change? Or do you want to avoid saying this? Because if you want to avoid it, like me, I'm not saying I'm taking the good approach, I'm just saying that it's an approach. If you want to avoid writing this until the end, when I switch to blue pen, I'm not going to call it rate of change, I'm going to call it average rate of change. So average lets me take this out just like it did with velocity. And then I can do y2 minus y1 over x2 minus x1. So I'm going to focus all my attention on the numerator, the big numerator, which is a fraction, two fractions being subtracted, so I need to do the 1, 2, 3 thing. And before I forget, 2 minus 2 is 0, and I'll have to divide by this h. So, denominator. Multiply the two original denominators together. That's 1. Go in this direction first. 2 times 2, 4. Lay down a subtraction sign, and if you think you can handle it, multiply all these pieces by -1. So -4, -4h, -h squared. You have to decide whether you're capable of that or not. So now, collect like terms. Those guys are gone. And I'll turn that into a times 1 over h. My denominator will stay the same. And when I mean the same, I mean actually the same. In my numerator, these two pieces are left. I'm going to take an h out, which leaves -4 behind for here, and -h behind for here. This h is being multiplied, this h is being multiplied. So my average rate of change is equal to -4 minus h over 2 times 4 plus 4h plus h squared. So because I chose to take out the limit as h approaches 0, by the way, it's always h approaches 0, you never approach any other number, you want it to be super, super small, I'm actually asked for the rate of change, which means I better change to blue. And if I change to blue, that also indicates that I had better change my communication on the left-hand side. So yeah, unfortunately you do have to write this thing down again without making any changes, because that's what rate of change is equal to. You need to mention that you know rate of change uses limit as h approaches 0. And now, because you can put this in, all your previous work was done in red, you get to put the 0 in. And at this point, you can show as much or as little work as you want. So plus 4 times 0 plus 0 squared. So 0, 0. -4 over 2 times 4. -4 over 8. And yes, you have to reduce all your fractions. And there's your answer. If I take a quick peek at what the question was, it didn't give me any units at all, so I can't imply any units in my therefore statement. So in this case, she's done. So I'm going to flip to the next one, which is the last one. It might take us 2 pages, but it is the last question. Our time together is over. I'm so sad. Actually, I kind of am. There's the question. I'm taking a little break for a hand cramp. All right, heads up that there is a question that I'm not going to do for this particular question, but I want to discuss it in case you ever run into the problem. As you can tell, I left out the conjugate method. We did the common denominator method. I left out the conjugate method. It is possible. I just want to tell you that. So the first question, I'm going to move this out of the way. A water tank is drained so that its volume is represented by V at T is equal to 30 times 20 minus T squared, where T can only be values between 0 and 20, including 0 and 20. V is measured in liters and T is measured in minutes. Now, why is the formula only good for this? Well, first of all, the 0, you can't have negative time, so it's got to stop at and start at 0. And if you look at the formula, if you put 20 into this bracket, it'll be 20 minus 20. 20 minus 20 is 0. Squared is still 0. Times 30 is still 0. What that means is that the tank is empty because it is being drained. So that's why the formula has this. Most of the time you can ignore this, and sometimes you can't. So it's best to at least notice that it's there and think about why it's there. So I'm pretty excited by this first question because I see the word average. That means no limits whatsoever. It says determine the average rate of change of volume during the first 10 minutes. So a lot of people will start their list and go all gung-ho and not have the right information in place. Now, almost everybody does that just fine. I'm going to put minutes, just so I have it written somewhere. But a lot of people will put 1 here, when really, when I'm asking for the first 10 minutes, we're starting at the beginning of this story, which is at the 0 minute mark. So now I can put 0 in. 30 times 20 minus 0 squared. That's 20 squared. 20 squared is 400. And that's 12 with a 0 and 2 more zeros, and that's liters, just so I remember. If I go on and use my space wisely, V at T2 is equal to V at 10. So that's 30 times 20 minus 10 squared. 10 squared. BEDMAS says do exponents first and then finish her off. So this makes sense that the starting value of water in the water tank is higher than a time between the 0 and 20. So now I can just do the average rate of change. Piece of cake. And it's rate of change of volume, not that that matters. So V at T2 minus V at T1 over T2 minus T1. 3,000 goes first, minus 12,000 goes second, over 10 minus 0. That's negative 9,000 divided by 10, which is negative 900. So here's where our lingo comes in. The volume is changing at negative 900. Changing is a non-directional word. Liters per minute. So the next question is to determine the rate of change of volume at 10 minutes. So notice I took out the word average. This is where we have to go full scale. I'm going to take this question to the next page because I'm pretty sure I won't have enough room. And I want to draw your attention to this question down at the bottom, which is a brand new A. And I'm wondering if you can tell me if you can see the difference between this version of A and this version of A. Because they both start with determine the average rate of change of volume during, and then this one says the first 10 minutes, whereas this one says during each of the first 10 minutes. When somebody says each of the first blah, 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 basically that means you've got a ton of work to do. Not hard work. Probably what you're going to think of as dumb work. Because if I ask you for the rate of change, even average rate of change of volume, you're going to have to do 0 to 1 with time, and then 1 to 2 with time, and then 2 to 3 with time, and then 3 to 4, and then 4 to 5, and then 5 to 6, and 6 to 7, and 7 to 8, and 8 to 9, and finally 9 to 10. So you would have the equivalent of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these questions. So I do want you to be aware of the language. I'm not doing 10 of the same question over and over again. You're supposed to be happy when it's just during the first 10 minutes, generally during the first 10 minutes, or whatever time period they ask. But when they start asking for each of the first 10 minutes or each of the first 20 minutes, it's a lot of work. So all these, just for the record, are times. Now let's look at the last part of this question, where it's determined the rate of change of volume at specifically the 10-minute mark. So at the 10-minute mark, how fast is this water tank draining? So with this question, I've just printed this here so I didn't have to write it down again and keep bopping back and forth. But I have specified for you a time, which means I've sneakily given you a second time. Be aware of where you have done previous work. And this is where the actual work kicks in. It's not going to be pretty. 30 times 20 minus, there's that minus sign again, t plus h, all of that in a bracket squared. I do not want to triple FOIL this. I'm going to run a negative through the bracket and collect like terms. Whew, there's like terms. And now I'm going to break that bracket down twice. And again, this is not difficult. It is very easy to make a silly mistake. I've already done with this note, caught it, but it's very easy to make a silly mistake. So don't beat yourself up if that happens, but this should not be all that difficult. And finally, collecting like terms. And if you see me make a mistake, you yell at me. So I'm going to see if I can sneak some of it in here. So I'm going to start with average rate of change because I don't want to write down that limit stuff. And I'm actually not going to write down the actual formula this time. So I'm not going to write down V at T2 minus V at T1 over T2 minus T1. I'm just going to plunk the stuff in. So this is V at T2 minus V at T1 over T2 minus T1. These will cancel. and these will cancel and make 0. In the denominator, there will be an h, which I don't want there because I know eventually I'm going to bring in limits. And the two chunks of information, the two terms that I have remaining here, both have an h in it. So I'm going to remove the h at the same time as my line of neatness. And you'll notice that yes, you can take out more than an h. There is no need to do that because the whole point is to eliminate the problem so that you can move on and do what's actually being asked, which is not average rate of change, it's just rate of change. So time to dig out the blue pen, time to change the left and include more on the right. I've dealt with the mathematical issue of putting a 0 in for the h's up above in the red space, and I end up with this. Now if I look back to the part A, I said the volume is changing at negative 900 liters per minute. I'm going to switch things up here for fun and say therefore the tank is draining. That's a directional word. And if I use a directional word, I can take out, I can take out the negative and say that it's draining at that many liters per minute. And we have our we're done. We have our overall therefore statement. So this last slide, because I got semi-organized, is the questions in the booklet. A couple of challenge ones for you that are attached to 1, C, and D. Tip for you is if you notice any of these kinds of questions, notice them and skip over them. I believe I kept one in there just to test your knowledge of vocabulary. So that is that, and I will bid you farewell. I'd sing the Sound of Music song, but you don't want to hear my voice. Bye!